I think you'll notice that I did not cut the piston off the length yet, nor did I take it out of the Alloris Dorian holder. And the reason for that is that now I'm going to drill the hole. I've already laid it out, and it's 1/8 of an inch from the end, and of course it's in the center this way. And you want to try to keep it on center, but the reason I left it in the holder is that I would like that hole to be perpendicular to the slot. And since we've already established that it's parallel, the slot is parallel with the bottom edge of this holder, we know that if we keep it in there and put it in the drill press or the milling machine and we drill that hole, it's going to be perpendicular. And that hole is only a 3/32 hole for that little wrist pin. And very close to the edge. And this is kind of a little intricate job here. Believe it or not, as simple as it seems, you know, to do this and do it properly is a little bit tricky. So take your time on this, think about it, and I will drill that then off camera. And I'm going to use the precision drill for that. And if you have a precision drill or what we call a sensitive drill, use it. The hole has been drilled, and of course there's a horrendous burr on the bottom, and I got to get the chips out of the hole, and then I'll use my little needle file to get the burrs out of the slot. Then it's ready, well, it is ready, to take out of the Dorian holder finally. Do a little hand work on it, then I'll take it back over to the lathe and take the cut-off tool and cut it to length. And it'll also give me a little chance to polish that, clean that up, get that burr off of there before I cut it off. And then think of all those things before you cut it off and paint yourself into a corner. It's just so easy this way, and compared to working with a relatively small piece like this. And then as I cut it off, I'll also run a file across there and chamfer it just about halfway through my cut, and that'll give me just a little bit of a chamfer on the top of the piston. I polished just a little bit with 500 grit paper and started my cut there with a rather narrow cutoff tool, and the piston is to be 1/2 inch long. The piston being done, I've already got a bit of a start on the connecting rod, and there's a lot of different ways to do this, but on this engine the connecting rod is simply made of that hobby brass. That's $2.15 for that piece, 64th thick, or 64 thousandths thick and 1/4 inch wide, and that can be used just as is, and I did. I, however, prefer the appearance a little bit more if the connecting rod is tapered just a little bit or designed in some other way without too much work on it. So I've already taken some of this brass that I've used for other purposes, and it was pretty well patinaed or tarnished because it's 80 years old, but as good as new. But I put a bit of a taper on that. Can you see that? That this is smaller here than it is down here, and I still don't know what the overall length is to be. That is to be determined, but it's plenty long. And I did that on the belt sander, because my milling machine has a setup on it. I didn't want to take the time to mill that down, so I just took it down roughly to a taper, what to me was a pleasing taper. And now I'm going to drill a hole in the end for the wrist pin, and that again will be 3/32. I'll use a 3/32 brass for the pin, and I'll do that off camera. And that needs to be fairly close to the end, because as you can see there isn't a whole lot of room for it. But if I'm too far from the end, I can always just take a little bit off of the end of the brass. This could be steel, it doesn't have to be brass, but I like the looks of the brass. And I'll drill that hole off camera and get right back to you. Okay, the piston is done and installed onto the end of the connecting rod with that pin, and that's in there for good. That's done. This is still way too long, length to be determined, but I ran into a little snafu here. And as you come to the end of a project and you start assembling it, you're going to find that there are different interferences and so on. And that is typical if you do not have a working drawing. And I do not have a working drawing, but I know this is all going to work because I've made one before. But using this transfer punch now, just as a indicator here to show where the center line of the bore is. And by the way, this has already cured the Loctite onto this. Oh, a little tight here. Why is that so tight there? So this is all assembled and done. Maybe. This is actually a little bit too thick. So I think I'll have to take the crank pin out of there and face this off. And I'll show you why. Because the center here, look at the point on the center, runs right into the crank. So I'm going to do two different things. First of all, I'm going to reduce the thickness of this so that it's the same thickness as this crank disc here, which is about 1/4, and this is more like 5/16. So I'm going to face that off camera because that's just mundane, easy work. But I have to take the pin out to do that. And then secondly, I see that I have reduced the length of this on this model from the original casting. So I will mill or file some of this off the end, perhaps 1/8 of an inch. And I knew that when I made the castings. I made this extra long, and it's so easy to trim something compared to just the opposite where it isn't long enough. So I'll trim that off about the end here where you see my scribers and what I just showed you there, and get back to you in a few minutes. This is just a real easy fix. That only took a couple minutes, but I faced off the side of the crank here and took a little bit off of the bearing, and I may have to take a little more off, but I can always do that. And I believe it's too long on this side too, as I remember. So bringing that up against there. Now I'm going to determine the length of the connecting rod. So installing the piston, and there's a little bit of oil on it. And I need to determine the length of it. So bringing the piston up to top dead center, and I want it to be a little bit below the steam port. So in other words, top dead center isn't going to be up here. It's going to be right about there. Then with the crank in that position, and then double checking again that didn't move on me, I'll take my marker and I'm going to cut it off right here. And then again I'll lay it in here off camera and double check everything and decide where I need to drill the hole, which is going to be approximately right here. But I'll mark that after the long piece here is out of my way. And then while I'm at it, I think I'll show you this too, that I have brought the crank over to this position and pretend that the little circle is the hole. And that's the way, that's the finished dimension. I will look in the end of the bore here to make sure that there's plenty of room and the piston isn't going to be coming out of the bore on the backstroke. And there's plenty of room there. In fact, I could have made the piston a little bit longer. But it's going to be just right, actually. So I'll go ahead and cut that. I have indeed cut the connecting rod off to length, and I've got it assembled. And I had to cut just a little bit off of the crank pin here. And I told you, I think originally, that I made it extra long to length to be determined. And I'm test running it. I know, just with a drill. And looking in the bore now. Looking in the bore. There. You can see the length of the stroke. Yeah, we're not too far from being done here, are we? Now, in order to assemble it, if I can take this old drill off, what I've done here is I have to bend a little bit or force the connecting rod off the pin, and actually I want that so that it can't come off. Now, this might prove to be a problem as it wears in, and if so, I'll put a keeper on the end, which I think I showed you on the other engine. And I've noticed that I've got just a little bit of clearance here, and if there's any interference here where this starts striking right here, I'll put one of those fiber washers in there, or a very short piece of that 1/8 inch brass tube as a spacer. So there's all kinds of ways to space things out and to get your final dimension. And this is, notice there's just a little taper on that connecting rod, and that's the appearance I happen to like. But some people like to do something a little fancy down here with this end, and you certainly can do that. You can make this thing as simple or as complicated as you want. Alright, this side being done, unless I make some minor revisions, and the head being done, I will turn my attention to, and the flywheel being done, to the eccentric and the spool valve, the piston valve. But I believe I will do the eccentric first, and I've got a bunch of these made up, and I always refer you to other videos that I have where I make these, but in this particular video I think I'll go ahead and make one from scratch using my little jig. It only takes a few minutes, but so that you can see that done without going into my other YouTube videos where I show you, I think, about 3 different ways of doing this. I'm just going to show you one way now, and that's with a little fixture or jig that I've made years ago. But tubalcain's tired now, and I feel like a cup of coffee and a piece of pie, but since there is no pie on the premises, I will have a couple fig Newtons, and I will see you in the morning. Good morning again, and let's get right to work today. I had this in my scrap box here, just wanted to show it to you that this is a crank that I had made that could be held on with a set screw. So that's one of the alternatives. Also, this one had 2 holes here because I was experimenting with the stroke on an engine. That was some time ago. I don't remember exactly why. Alright, back to this now. There's a couple things that I'm going to do, and I'll do them off camera actually because they're so simple. But the bearing right here is too long. Looking at the other one here, the distance here is a 1/4 inch. Now I've already marked that, and I'll take the shaft out and mill or sand it down to that line. It's not too critical. But the reason for that is that the eccentric has to line up with the where is it here? With the center line of the valve. And that is too long there, so that's why I'm going to trim it. And I need a steam hole. The input is going to be right there. That'll be a 3/16 diameter hole, reamed, and it's right on the center line, and it's in from the end here, and it's not very critical at all, but it's 1/2 inch in from the end here. Now on this particular one, that's just 1/8 inch tubing, and on the one that I made last month, this was 3/16 and it was threaded in. But I'm going to just use brass tubing, and this is 3/16 OD, and that will be held in with Loctite. So I'll go ahead and do these 2 things, and I'll get right back to you. In the last few minutes I've drilled and reamed this hole, and the tubing, which is about 1¼ inch long and 3/16 in diameter, has been Loctited in, and that'll take a while to set. And I've been careful here such that I didn't insert this so far that it will impede the valve that'll be moving back and forth, so I've just double checked it with the 3/16 reamer. And then over here I have trimmed this, and I just used my little hobby hacksaw to saw that off, and then filed it so that it's nice and square. One other thing that I did off camera, and actually this was yesterday, on the connecting rod I drilled this hole originally 1/8 inch, or reamed it 1/8 inch, but I opened it up a little bit to a number 30, and a 30 is about 3/1000ths larger than 1/8 inch, because you don't want any binding here. You want this to be able to move and to be a little loose, so it's just a little bit oversized. And I do that on most of the engines. And remember that you do not want any tight spots. If there's anything that's tight or is binding, deal with it now, because you've done something wrong, because it'll only be more aggravating as the project continues. Next, I'm going to go ahead and make the eccentric. Now, I've already got several of these made up, and I have shown in several videos, or at least one video rather, I have shown how to make these and several different methods, but I'm going to run through this real fast again so you don't have to go back to that video, but you can if you want. But using brass and 3/4 inch would be just fine for this, but for some reason, I don't know why, I've used an odd decimal size here, about 780. I don't know where this brass came from, but it's already got a 3/16 hole drilled and reamed in there from some other job. But I made this little fixture, jig, or whatever you want to call it, years ago. And remember that I'm going to have a total of 1/4 inch travel with this eccentric. In other words, the valve is going to move 1/4 of an inch. I'm going to change the order of things here just a little bit, but before I show you how to make the eccentric, I believe I will make the eccentric strap. It's a rather tedious thing to make, and I'm going to run through it rather quickly. But getting back to the eccentrics, be sure and watch Machine Shop Tips 160 on eccentrics for a more detailed explanation and the different ways of doing it. And remember, the word eccentrics simply means off-center. I've already prepared a piece of sheet brass, and it's about 43/1000 thick. Not about, it's exactly 43/1000 thick. And I've laid this out. I started by making a 1/2 inch hole. And there are different ways of doing it, but these Christmas tree type unibits just work great for that, because there's no grabbing. But once that was done, well, actually before, I laid it out with a dividers and swung both the 1/2 inch circle and then this larger circle, which is a 7/8 diameter, and then drew in this strap part here. That's 1/4 inch wide and about 1 3/4 long, and really that's much longer than what we need, and I will trim it as necessary when I'm done. So my method of doing this, and the brass is a little bit tricky, is to just band saw it out or roughly, and then take it to the belt sander and sand it round, and then either mill or sand this strap part 1/4 inch wide. Got to keep it cool because it gets hot very quickly and burns your hands. But this could be made out of light steel too, but I like brass. And if you can't get a hold of any brass, just use some sheet metal. Over to the bandsaw I go, and I won't show that. Well, there it is. That took 10 or 15 minutes on the bandsaw and the little band sander. Now, if you do not have those luxuries, you certainly can do it with a jeweler's saw and a set of jeweler's files or small files, and tempered with plenty of patience and elbow grease. But there we are. That's done, except for the total length to be determined and a 1/16 inch hole. Now notice that this fits perfectly on the eccentric. So again, the eccentric device is set up already in the 3-jaw chuck, and I'm ready to turn this. I'm going to call that the throw. I'm not sure that's the correct name, but I've already got the hole drilled, and I'm using a facing tool with a rather sharp point on it so I can get in there and get a nice square shoulder. The carbide tools aren't going to do that, and I will take this down to 1/2 inch. Actually, it's just, this one is just a little bit under, and I want it to be a free fit. Don't get it so tight that it causes resistance or friction. So we got just a couple thousandths to play there. So let's take a look at the setup now on the closing lathe. And here it is. Now you may have to build one of these or whatever method you're going to use, but this is about a 2-inch diameter stock here with a hole drilled in there, and again the set screws holding it. And although the steel itself is centered pretty nicely in a 3-jaw chuck, the brass itself is of course off-center. And you can see how it appears to wobble, because it is now eccentric. Now, do not run your lathe too terribly fast, because this is out of balance. So you can determine that, but I'm only at about 500 RPM right now. But this lathe is big enough to absorb some of that vibration. If you have a smaller lathe, it may want to walk right off the bench. So be careful with that. Wear your glasses. This distance here is only, again, about 45 thousandths or so. Now here's how I like to measure for that, but of course there's many different ways. But I have brought the tool up until it touches the work, just lightly. And then I'm using a carriage stop, but you may or may not have one. But all I do now is to back the carriage stop off 45 thousandths, or you can directly use, loosen that, your workpiece as a way of measuring that. And then I'm going to back off, because I told you I wanted it to be just a little bit more than the thickness of the work. Tighten that, and now when I feed in toward the headstock, I just come up against that carriage stop.